Hello everyone, welcome back to Bamane Pharm Lectures, where we make pharmacy simple. In today's lecture, we are going to look at mEq as one of the units of measure used in formulation of injections. And in our previous lecture, we looked at the relationship between milliequivalents and millimoles. So today, we want to look at milliequivalents in details. So I want you to pay a very keen attention as we go through milliequivalents. And I believe at the end of this lecture, one, you'll be able to answer any question concerning milliequivalents, be it in theory or in laboratory practicals. When it comes to laboratory lab practicals, you'll also be able to answer any question relating milliequivalents, and you'll also be able to perform any interconversion involving milliequivalents. And also in our next lectures, you need not forget, we shall be looking at the topic where we shall be using how we can, for example, make solutions isotonic using milliequivalents. This is also a sensitive topic that is usually asked when it comes to laboratory lab practicals or even in theory. So I want us to pay a very keen attention as we go through this. And for those who are new to this channel, my name is Bamane and I am a tutor. So pick up your pen and a calculator and be very attentive as I take you through milliequivalents. What is milliequivalents? Like we talked about it last time, milliequivalent is simply the concentration of electrolytes per liter of blood. We are all aware that blood has got electrolytes, because it has got composition of certain ions in it, as we are going to see as we move on further. So, since it expresses the concentration of electrolytes per liter of blood, it considers the total number of ions in that solution and value of the ions. So when we talk about milliequivalents, there are two things that should not be forgotten at all times. That's the valence of the ion being talked about, and also the number of ions, how many ions are present in that solution. We shall be looking at all that, and by the end of the lecture, you'll be able to differentiate or be able to perform any calculation involving milliequivalents. Just pay attention. So when we say it's the number of electrolytes per liter or concentration of electrolytes per liter of blood, electrolyte ions in blood include in blood we have got a certain electrolytes ions in it, where we have both cations and anions. So among the cations, we have sodium ion, we have potassium ion, we have calcium ion, magnesium ions, and among others. We also have anions, where we shall talk about the lithium chloride ions, we shall talk about the bicarbonate ions, the hydrogen phosphate ions, sulfate ions. We also have proteins and organic acids. All these ions have got their milliequivalents in blood, as we shall look at it when we reach at this table. So that means that these electrolytes are specifically formulated to treat electrolyte and fluid imbalances in the body. And what happens is, these electrolytes in our clinical practice, for example, in hospital settings, they are given in form of oral solutions. All of us, we have ever seen oral rehydration solids, ORS. they are all electrolytes, but also by intravenous infusions. And under normal circumstances, blood plasma contains 155 milliequivalents per liter each of cations and anions. That means that in blood we have a total concentration of anions and a total concentration of cations. And always when we are adjusting solutions to isotonicity, or for example to determine whether that solution is isotonic with blood plasma, it must have a total concentration of electrolytes equal to 310. As we are going to see that, for example, the total concentration of anions is always equal to that of cation. So if you're performing any calculation or to ascertain whether the solution is isotonic with blood plasma, we must ensure that the total concentration of cations in milliequivalents is always equal to that of anions. For example, we can look at the average composition of ions in our blood plasma. You realize that we have cations. Which cations we have already talked about here? The sodium, the potassium, the calcium, and magnesium. And all of these ones have got a certain concentration of milliequivalents. For example, sodium ions, we have 144 milliequivalents per liter of sodium ions. We have 5 milliequivalents per liter of potassium. We have 5 milliequivalents per liter of calcium ions. We have 3 milliequivalents per liter of magnesium ions. And when we total up all of this, we get a total concentration of cations as 155 milliequivalents per liter of cations. And when it comes to ions, to anions, we shall have bicarbonate ions, which has got a total milliequivalent of 27. We have 103 as the milliequivalents per liter of chloride ions. We have also hydrogen phosphate 2. We have sulfate ions 1. We have proteins as 16, and we have organic acids as 6. So when you total up all this, it gives us a total milliequivalent of 155 milliequivalents per liter of blood. So the total concentration of milliequivalents for anions must always be equal to that of cations, as it can be seen from our table here. So what does that mean? That means that for any solution to be isotonic, the total milliequivalents of cations and anions must, we are using the word must because it must always be equal to 310 milliequivalents per liter of blood. At all times, you have the total concentration of milliequivalents at your fingertips because it is the major determinant when it comes to adjusting solution to isotonicity. Let us see what does milliequivalent and equivalent weight mean to us. Then we shall see how we can solve any questions concerning milliequivalents. Therefore, milliequivalent represents the amount in milligrams. Don't forget that. It represents the amount in milligrams of solute equal to 1,000th of its gram equivalent weight, taking into account the variance of the ion. So every time we talk about milliequivalent, we mean amount in milligrams equal to 1,000th part of its gram equivalent weight. But we need to know, what is equivalent weight? Equivalent weight is simply the ratio of ionic weight or molecular weight of a substance to values of the substance or ion. So every time we say equivalent weight, we mean molecular weight divided by values. At all times, these are the key equations that are going to lead us into any interconversion involving mean equivalent. So, if equivalent weight is equal to molecular weight over values, remember that 1 mean equivalent, based on our cost definition, 1 mean equivalent will be equal to 1 out of 1,000 times the gram equivalent weight. Gram equivalent weight. A thousandth of each gram equivalent weight. So, but we know that gram equivalent weight is abbreviated by capital EQ, like that. But also, we know that mean equivalent is equal to mass in milligrams over molecular weight of a substance times values. If we can call this our equation 1, remember milligrams divided by molecular weight is equal to millimole. So if we call this our equation 2, that means if we substitute equation 2 in equation 1, the equation becomes, that means that we shall have, if we substitute this into this equation, we shall have mean equivalent being equal to, now where there is mass out of molecular weight, we shall put millimole being multiplied by values, and at all times this equation should be at your fingertips because we are going to use it so many times. So what does that mean? This means that every time we are moving from milligrams to millimole, every time you're converting from milligrams to millimoles, we divide the mass in milligrams by molecular weight. And every time we are moving from millimoles to milliequivalents, we multiply millimole by values. And this should be at your fingertips at all times. So these are the two most important equations that we are going to deal with when it comes to any interconversion involving mean equivalents. Let's look at our first example. So our example 1, how many mean equivalents of potassium chloride are represented in 15 ml dose of 10% weight in volume potassium chloride solution, they have provided us with the molecular weight of potassium chloride. So the beginning point here is to first calculate the equivalent weight of potassium chloride, because we know that equivalent weight is the amount in milligrams equal to 1,000 of its gram equivalent weight. So the first thing we need to ascertain is the equivalent weight of potassium chloride. So we shall say equivalent weight of potassium chloride will be equal to, we know it is molecular weight divided by variance. But already we know that the molecular weight of potassium chloride has been given as 74.5. But what is the valence of potassium chloride? We know potassium chloride has got a valence of 1. Cation is, the cation is in that compound determines the valence of the compound. So in this case, we have a valence of 1. So when we compute this, we shall have 74.5 grams. So that means the mean equivalent of potassium chloride is 74.5 grams. So from here, we shall come and get the mean equivalent. But we know that 1 mean equivalent of potassium chloride is equal to 1 out of 1,000 times the equivalent weight. But we have obtained the equivalent weight, which in this case is 74.5 over 1,000. So when you divide this, we shall get 0.0745 grams. But remember, in our definition, we say it is the amount in milligrams of a solid. So we have to convert this into milligrams by multiplying by 1,000. So this will give us 74.5 milligrams of potassium chloride. So after obtaining the mass, the mean equivalence of potassium chloride, that means the mass, we have obtained it. So this is the mass in 1 mean equivalent of potassium chloride. But our question, we need to know what mass of potassium chloride is in 15 ml dose of a 15% of a 10% weight in volume solution. So we need to get the mass in 15 ml of potassium chloride. But we know that 100 ml of potassium chloride contains 10 milligrams, 10 grams. How about the 15 mils? This will contain 10 out of 100 times 15. And when you compute this, we are going to get, for example, this is 15, this is 10, this will go with this. And when we compute this, we are going to get 1.5 grams of potassium chloride. So we have 1.5 grams of potassium chloride in 15 ml dose. But we need our answer to be in milligrams, since we know that 1 ml equivalent is containing 74.5 milligrams. So that we can create a uniform unit. So convert this in milligrams, we shall simply just multiply by 1,000, such that we get 1,500 milligrams as the amount of mil equivalents in the 15 ml dose. So from there, what we are going to do, we are going to write from first principle, where we know that what we are looking for is the mEq. So we shall begin from here and say 74.5 milligrams of potassium chloride contain 1 mEq each of potassium and chloride ions. How about the 1,500 in the 15 ml dose? This will contain 1/74.5 times 1,500, and when you compute this, we shall get approximately 20.1 mEq of potassium chloride in 15 ml, and that is how we can go about a question of that nature. Let us look at our second example. In example 2, how many milliequivalents of calcium chloride are in 2 grams of calcium chloride? They have given us the molecular weight of calcium chloride. But as I said, the first thing always to start with is calculating the equivalent weight of the compound given. So we shall begin by calculating the equivalent weight of calcium chloride, which we know that is equal to molecular weight of the substance, which in this case it is 111 divided by variance. Calcium has a variance of 2, as we saw in the table. So we shall divide this by 2, and the answer will be 55.5 grams. Remember, we said the equivalent weight is written in grams. So from there, we shall say 1 milliequivalent is equal to 1,000 of equivalent weight. In this case, our equivalent weight is 55.5 grams. And when we compute this, we shall get 0.555 grams of calcium chloride as our mass in 1 gram. But remember, we said that mEq should be in milligrams. So we are going to convert this into milligrams by multiplying with 1,000. So when we multiply with 1,000, we shall get 55.5 milligrams of calcium chloride. But after getting this, remember this is not the answer. We need to ascertain how many milliequivalents are in 2 grams. So the first thing we are going to do is to convert the 2 grams into milligrams. But we know that 1 gram is equivalent to 1,000 milligrams. So that means that 2 grams will be equivalent to 1 out of, it will be 1,000 divided by 1 times 2, and this will give us 2,000 milligrams. So after knowing that 2 grams is equivalent to 2,000 milligrams, we shall write from first principle. Remember, we have said that 1 milliequivalent is equivalent to this mass, but our main time we are looking for milliequivalent, so it should be on our right. So we shall say that 55.5 milligrams of 55.5 milligrams of potassium of calcium chloride contain 1 milliequivalent each of calcium and chloride ions. How about the 2,000 milliequivalent of calcium chloride? It will contain 1 out of 55.5 times 2,000. And when we compute this, we shall get approximately 36 milliequivalent of calcium chloride. And that is how we can arrive at the answer. Or else, you can also use the formula. It will still give you the same answer. In your free time, you can also calculate for the milliequivalent using the formula. It will also give you the same answer, whereby the mass should be in milligrams, which we have already obtained, divided by the molecular weight, which we know as 55 times the values. Let's look at our third example. In our third example, let us try to use the formula. We know from our formula, we say milliequivalent is given by milligrams over molecular weight times values. But remember, they have given us the mass of calcium chloride. We need to convert this mass of calcium chloride to milligrams. But remember, we said 1 gram is equivalent to 1,000 milligrams, about the 0.16 grams, to be equivalent to 0.16 times 1,000, which gives us 160 milligrams. So it means our milliequivalent will be equal to 160 divided by the molecular weight, which in this case it is 40 times the values. The values of calcium is 2. So when we multiply this, we realize that this and this will cancel, and from there we shall have 4 into this, we shall get 4 being multiplied now is a 2, and when we compute this, we shall get 8 milliequivalents of calcium. If you decide to do from first principle, still we shall get the same answer. We know now that if we get the equivalent weight, for example, equivalent weight of calcium ions will be now 40 divided by 2, which is the values. So we shall get our equivalent weight as 20. So we know that 1 milliequivalent is equal to 1 out of 1,000 times the equivalent weight, which is 20. And when we compute this, we shall get 0.02 grams. But remember, we say it should be in milligrams. So what happens is we shall multiply this by 1,000. And when we multiply this by 1,000, we shall get 20 milligrams. So from here, we shall say now that 20 milligrams of calcium ions contain 1 milliequivalent. How about the one in the formula, which is 160? So this will be equal to 1 out of 20 times 160. This will cancel this, and this reduce this to 80 milliequivalents. So any formula you use will lead you to the answer. Let's look at our fourth example. So our fourth example, you can feel free to pause this video and calculate it out and see whether you can arrive at the same answer with me. Here, they want us a solution contains 10 milligrams per 100 mils of a solution of potassium ions. Express this concentration in terms of milliequivalent per liter. Just say milliequivalent per liter, it gives you a clue to tell you that we need to convert these 10 milligrams in 100 into 1,000. So that will be our beginning point. So we shall say if 100 mils of the solution contains 10 milligrams of potassium ion. How about the 1000 mils? This will be 10 out of 100 times 1000. And when we compute this, we shall get 100 milligrams per liter. So after knowing what is in a liter, we shall come and get the equivalent weight of potassium, which will be equal to 39. We know that potassium has a valence of 1, so it will give us 39 grams as its equivalent weight. So that we know that 1 milliequivalent is equal to 1 out of 1000 times the equivalent weight, which in this case is 39. And when we compute this, we shall get 0.039 grams. But remember, we said milliequivalent should be in milligrams. So we shall multiply this by 1000 such that we can get 39 milligrams of potassium ions. So from there, this is not the answer. Our main aim, we want to ascertain how many milliequivalents are in a liter, but we know this is the mass which is in 1 liter. But we have the relationship between milliequivalent and milligrams. So we shall say 39 milligrams of potassium contains 1 milliequivalent. How about the 100 milligrams? This will contain 1 out of 39 times 100. And when we compute this, we are going to get 2.7 milliequivalent of potassium ions. And that is how we get the answer. I hope you have got the same value with me. Let's look at our fifth example. Example 5 is our assignment. I want you to pick up your calculator and a pen and calculate out this number now and comment with your answer in the comment section. I'll be happy to tell you whether you got it right or wrong, and we shall do the correction in our next lecture. Don't miss, in our next lecture we shall be looking at how we can use milliequivalents to make solution is isotonic. And please, if you have not subscribed to my channel, please do so that we can keep you updated with more simplified pharmacy lectures, and also keep our channel grow so that every other students out there can reach out and study pharmacy in a very easy way. If you have any question, please feel free to ask in the comment section. And if you have any topic you want us to cover next, you can as well drop it in the comment section. I'll be cross-checking back so that you can cover those topics. Please like the channel, turn on your notification button so that you can be kept updated with more videos to come. And also don't forget, share the channel with your fellow colleagues and other classmates who may also find this very useful. Let's catch up in our next lecture. See you.